Good afternoon. It's time for day 4 of Advent of Code. Let's go. So, okay, we need to look for Christmas inside this input. So let's take this example input and let's start. Here we have our example. Pass the input here and we can go on with creating the solution. Okay, with grids, what I like to do is to create a struct to make it easier from my side. So let's create a grid which has the actual grid inside, which is just a vector of chars. I want also the height and width. They are use size. Now I want to test this class. So let's do it. How can we test this class? We can start from some smaller test cases, maybe. We can just go with the full one. So let's write some implementation for this grid. First is the new. The new takes our input string and returns itself. So maybe we can test this creation. So test can create a grid. Now we pass an input which is not the example. Let's pass a smaller one like let input be this string. We want to have a grid which is grid new of input, and I want the grid to be 3 by 10 or 10 by 3 by 10. How can we do this? So first thing, cargo test bin 04. It's not even compiling. Let's return a cell. We return a grid height of, let's say, 0, width of 0, and the grid. Let's just pass the characters. So input chars should compile and should fail. Yes, it fails. So how can we compute these two values? We compute the height by doing, we get the lines. The lines are input of lines collect. We are getting a vector of the references string. The height can be the length, and for the width we are sure to have at least one line, so we assume that, and we get the length of that line. Now as for the height and width, we should be fine. I think we can just remove this and use the variables. What about the characters? So these have some new line characters. We want to remove that. We want to remove every white space in here, so we can just, so we get every characters. We filter out the white spaces. So if it's not a white space, we then collect them into the vector. This should be our new grid. And we have our test passing. So let's keep it at none for now. So I can see some green while I'm developing. Okay. Now I want to assert how many Christmases are here. And this is already difficult. Now, how do I want to count the Christmas? I want to do like the problem does. So in here, it's doing this thing, which is replacing the x's, all the strings which are not Christmas in the right way. He's removing every letter which is not involved in a Christmas. And how do they do that? So we need to check for every, we can do it in we can do it in passes. So first we remove every X which doesn't have any M's around. Same thing, then we remove every M which doesn't have any x's around. We remove every a which doesn't have m's around, and we remove every s which doesn't have a's around, and then we count the s's remaining. So we can write a pass for this, and I think I have an idea, so I can just write a function which is called pass. I want to have the mutable reference to me, so we have a self. Was that mute self? And I want to have two characters. The first is the character I need around me. So around me, I know the characters involved, which is a char, and the characters I have to have around, which is another char. I return nothing because I mutate the grid. Now, let's do it in a single. Let's do it a pass in our test. So, for example, test pass. I have this grid, and I want to. This is a mutable grid. I want to have, for example, make a first pass, which is pass of any x characters that doesn't have around an m. Okay. Now, how can we assert this? I have this thing, so let me do this, but I shouldn't. And let's get our expected output. The expected is this. For example, I want to remove every m's which doesn't have an x around. How can we do that? Say, again, let's do it like this. I want to remove, for example, this m here, and I will put a dot on it so that we can remove that. This m doesn't have any x around. Same thing for this m is okay, this is okay. These two are not okay. Same thing here. This is okay, these are okay, this is not. Right? Don't have any x around. Again, this one, okay. So I want this expected output. Let's remove any space from here, from there. Okay, so I want the output grid to be this one. Okay. After that, I am gonna assert that the expected output is output expected is our grid dot grid. I want to create a string. So from the characters, I need to create a string. How do they do that? I can just collect them, I think. So I can just iterate and collect them to a string. Should be okay. Can I do that? I can collect the characters into a string. And if I run the pass, it's not. Yeah, okay. That's okay. Grid moved. Oh, it's moved because I don't have a reference for mutables. It fails because on the left we still have the dash n. So this is not right. Why do we have line separators here? I'm still getting... Oh, the line separators are on the expected. So actually this was right. Different from C is white space. Now, okay, so let's fix the output. And that should work. Okay, now they're comparing in the right way. Let's create the pass. So the pass must look for any character which doesn't have. Okay, so we need to have a loop. So for y in 0 to self height, x in 0 to self width. Now I assume we have an around function, so I can count the around characters. We can do that. So self around of y and x, it returns a vector, or we can also say neighbors, and I want to filter out the characters which are different from my around, and I want to count them. No, that are equal to my around. I want to count them, and if this number is equal to 0, we can say that self grid of y and y dash y multiplied by I plus width is equal to dot. Now we need to write the around method. So for the around, the neighbors, actually, we have a self, we have the y, we have the x, and we have nothing else. We return a vector of charts, which represents our neighbors. Now let's create the neighbors. So neighbors. Let's just call it n. This is a vector of char, and it's for now an empty vector. For dy in -1 to 1, this is an i32, and same thing for dx in -1, 1. If now we can do it in a better way, but it's okay. We check 9 position, but we want the position to be different from 0. So if now this is a big condition, dy must be different than 0, dx must be different than 0. What we want then, the resulting y, which is equal to y plus the dy. This is a i32. I want the y to be an i32. Okay. Same thing for the resulting x. So the x and x. I want also ry to be more than 0 and to be less than I. I want the resulting x to be more than 0 and less than width. If they are this, then I can add to the neighbors. I can push self of grid of resulting y by width plus resulting x. And I can just return n. Now, this must be a new size. This is self width. And this is a condition. This is a push. Now, another thing I did wrong was not using self here and multiplying by the wrong thing. Plus x. This filter is still not working. This neighbors works. Now, why it's not giving a filter? Because this is not an iterator. We could try to create an iterator, but I don't want. I have a vector. And this is not working because we should do this with ground is a char, and this is a reference to char, double reference actually. Okay, let's see. Still failing. It replaced everything. Now we should replace something with a dot. If we need to test the neighbors function first. So for example, with the same input, same grid, I want to see the neighbors. For example, we test the neighbors. Let's create some tests. So this is not a test, it's an RS test. This is a case. The case is done with y, which is a new size. We have x, which is a new size, and we have the expected, which is a char. No, actually the expected is a vector of chars, so it's vec of char. This will be difficult. Now we need to import all of them. So we import rs test, and here we have to say, for example, let's see how we can translate this into our example. On position 0, 0, we want a vector of m. Let's do it better with this. We want, in this position, we have 3 neighbors. We have char m, m, and s. Now, the order, we don't care about the order. So we need 2 m's and 1 s. I mean, we can care about the order. So the order will be m, m, s. M, M, and S. Now we do that, we create a grid, and we say let actual equals to grid neighbors of yx, and we assert that expected. We remove this. We use it later. We test again. I want, okay, so even the neighbors are failing. And why? Why are they failing? So we didn't get any neighbor. That's okay. So let's fix these neighbors. Why? Because I don't think it's including the 1 here. Should be with 2. Now the neighbors still not working. Okay. Cannot be 0, 0. Okay. Should be more than and equal 0, less than equal 0. No, more than equal 0. Again, we are not getting the right neighbors. And why? -1, 0, 1. Oh, okay, see, yeah. I want them to be 0. I just want not to be this. So I want to not be 0, 0. So I can do this. I don't want to be in the center. Now it's returning something at least. Okay. So why? Let's do it in another way. We can create a pair of directions. A vector of pairs of directions. So we start with -1, -1. Then we go on to -1, 0 is y, x. Then we have 1. No, we have xy here. Okay, so this is still -1, 0. Y, -1, 1. Then we have 0, -1. Then we have 0, 1. Then we have other 3. So 1, -1, 1, 0, and 1, 1. So we can remove this ugly if, and remove this double loop, and we can say for the y, the x in directions, which is better. Now we have the directions, we have the resulting, we have the checks. So if the resulting y is more than 0, less than height, x is the same thing, we push. And we try again. Again, the neighbors are not working. I mean, 1, 1 is our M. So if we look here, 1, 1 should be S. So it's not returning 1, 1, it's returning one of the others. Let's see. Debug of dy, dx, ry, rx. Okay. Let's see which one. Oh, let's remove for a bit the single pass. We are not working on that right now. We're working on a single test, which is this one. We have dy dx. Okay, 0, 1. So y, x, and 1. What are the height and width? So let's see how is the grid. Just to be safe. Let's see how the bug self works. Reference to self. Oh, it doesn't work. Okay. Let's see it in the test so that you can check how is the grid. It doesn't have a print, so it won't work. Okay, so let's do grid height and width. The grid is okay, so the height is not right. No, because the input doesn't have the dash n we're expecting. So, okay. That's totally my fault. 1, 2, 3. 1, 2, 3, 1, 2, 3, 1. It's not right. It's not 10 characters. Let's copy it here. Okay. Now the neighbors pass. Okay. Let's try again with something else, like a more difficult one. I want in 1, 1 to have In 1, I want, which is this, I want 3 m's, MAAX. I want 9, no, I want 9 characters. 7, 8, and I want 3 m's. Okay, then I want an M, an A, AMX, AMX. Let's remove this thing. I can just use the example here, so I can also try with the example. I mean, position is the same. It's still working. Okay, so I'm pretty safe that the neighbors are working. Let's try with the pass here. So and the pass is not working. It did eliminate an M. Oh. No, why is there a dot in the input? Wait. The expected is on the left. On the right, we have a dot, which is totally unexpected. I mean, I don't know, we are expecting some more dots, so it's not working right. Why? Now, here we are removing the X which don't have M's around. So in the example, we have, this is a M. So it must also be the characters we are waiting for. So if it must be the involved character. So if the character in self in here is equals to the involved, then we see if we can delete it. Again, we should be removing X's, and I think I did the wrong expected, so let's try again. I need to remove the X's without M's around. I don't think this pass should work, but let's try again. So copy the input here. I want to remove X's in this test. So I need to remove X's which don't have M's around. And this is not a nice example. I want to remove M's which don't have X's or which don't have A. No, I want to remove M's which don't have X's. Okay, so this is the same example as before. We can try to check. This M doesn't have any X. We have other M's, other alone M's like this. This M doesn't have anyone. Again, this M is not having any X around. This one does. This one doesn't. We actually have 3 M's which don't have X's around. Yes. And this should be it. Okay. This is the expected. Let's see. It's not running. There's an M which was not eliminated in our method, which is the one on the, let's see, 1, 2, 3, 4, 5, 6, 9, 10, on the second row, 7. Second row, this one here was not eliminated. Why? SMSA. Actually, it should be eliminated. We were wrong. This M here doesn't have any X around. So it should be eliminated, and this pass should work. Okay. Now let's try to solve part 1. This is the neighbors. This is our neighbors. Okay, this is the pass. And now we can solve. How can we solve it? I want, in our part 1, to create a grid. In part 1, we create a grid, which is a grid created from the input. Now, I want to do some passes. The first is I want to remove any x without m's around. We have 4 passes. So we have every m which doesn't have an a around. Actually, I should do the opposite. I should remove any. I can remove any m's without an x. I can remove any a without m's around. And I should remove any s without a's around. The a's have been eliminated before. Now I can just count all the s characters. Let's try to write a function. No, yes, let's write a count. I want the char expected to be a char. It gets a self. It returns a new size. And this is just self grid iter filter for C, where C is different, it is equal to the expected characters, then a nice count. Now, this C is like this. So I just need to grid count the S characters as menu 32 and move some around. Let's see if these work. It fails. It returns 19. Okay, so let's see the grid. Let's try to print the grid actually. So we want to print the grid, and we can do that. How can we do that? We can print the first with characters, then the second with characters, and so on until the end. So, or we can just do this. For y in 0, set height. For x in 0, set width. I print single character, which is self grid of y by self height x. At the end, I print an empty string. So we can try to print here. Grid print after all the passes. It doesn't compile because this print must get a reference to self. Okay. We didn't remove anything here. Why? That's unexpected. I mean, we tried to remove stuff. It should remove stuff. It did only in the first 2 lines, the first 2 rows, and here in the last. Maybe there's something in our pass which doesn't work. There is the debug print here. There are too many debug prints. Again, the print is wrong. Print is wrong. Let's print the actual one, which is still not what I expected. Now, maybe our passes were wrong. We want to remove, we don't want the first line. Again, it's not working as expected. We want to remove FEM without axis, which worked in the first line. So it's not working. Should remove a lot more S's. We're left with one more, which is frustrating, I would say. Maybe we can change the condition to remove a letter. For example, we can check on all directions if we can get well, okay, maybe this entire pass thing was not what I meant. I expected to remove a lot more. Because, for example, these S have some A's around. These A does M some M's around, but they're in the right direction. Okay. Okay, so it was not right. Let's see. Okay, so I'm not able to remove the right number of characters because this should be a pass over 2 characters. So, for example, I can remove the A, not if it doesn't have any M's around, but I could try to remove any A. No, can be removed. Okay, because it has M, but it's not the right kind. Okay, this was pretty wrong. Let's see if we can check something else. Instead of checking the neighbors, we can check each position for the Christmas and just count Christmases. So, or we can do the same thing as before. No, we can just check the positions. So, for example, instead of getting the neighbors like this, I can try something else. I can try getting the entire Christmas, the entire Christmas string from a direction. So we can, instead of getting the neighbors, we can get a string from a given direction. For example, from up, we can get the -3, -2, -1, and our position. I can try to get from the upper left, from the upper right, and so on. So we can write all the directions. Yes, we can try that. In a given direction, which is a tuple of i32, i32. I want to check if it is Christmas, or if this, or I want to get the string in a certain direction. Oh, okay. Let's try again. I want to check in that direction. So let's remove all the pass. We can still use the neighbors in a similar way. So we can reuse this code. Let's try to see the check, maybe. No, I will. Yes, let's write a. So we don't want to test the pass. We want to test the check. Or we want to get a string. We want to get a string from a certain position in a certain direction. Okay? Let's try. So let's test the get string. I want, for example, let's use the example grid again. So from the input grid, test get string. From the input string, from the example grid, I want the input. It's not working. I need to pass. Okay. I want to get the string from 0, 0 in a direction which is +1, +1. So we're going down on the left. This is the direction. This is the string. I want, it's not a boolean, it's a string. So this is a string. I want the string to be Christmas. I want, let's just check if it's Christmas. No, let's get the string so we can then update the method. So I want to assert that this is equal to something in position 0, 0, down of 1 for how many characters? Let's say 3. Here I want to get MSX. MSX. When I check for string, the get string also get a length, which is a new size. How can we do that? We can do it with a for. So for example, for in 0 length, get the resulting y is a mutable. No, we don't even need that. We can do it in a nice iteration. So 0 length map. We have an index. From the index, let's do it without force. From the index, we can multiply by the direction. And we get, I think, the pair of directions. Then I can filter out any direction which is not inside the. So I have y and x. I want, I mean, the resulting y and x thing. What is the returning? I think this is not right, but let's see. I want to remove now this one, which was the condition we had before. And I want to, again, map it from a given resulting y and x to our grid characters. So cell y by self width plus x. I want to collect them into a string, which is the resulting value. This is pretty wrong. We don't know the type of this, but we need to have y by direction of 0, y by direction of 1. And this is wrong because I is a new size. I want it to be an I32. I32. I want this to be ry, the resulting y, the resulting x. Same thing for here. Resulting x. We're expecting something else. And this is ry, ry, rx, and rx. This works, and this doesn't, because I need to put this asterisk over the no, it's not. This is an I32. This is an I32. This must be a new size. We must do as new size. And it's not working. First, the self width is an I32. So as I32. No. The type char cannot be, okay. And then I do, or I can cast Rx and Ry as new size, because by this time they will be, I think, as this should give us the string we want. It's not compiling, but why? Because they're not used. I need to start from y and x. Again, as I30. I'm doing a lot of casts I don't want to check. It's not compiling. Why? Because we're still doing the thing. So let's return none here. Okay. So it's compiling and the test is green. Let's try again with something more difficult. Let's get string 2. We will get a nice name. Still from the example, I want to go in a different direction. For example, on 3, here, I want to go horizontal. Let's write test cases for this. So if I do, instead of this, I can just run another RS test with some cases. I want in position 0, 0 with the direction 1, 1 for 3 characters to get the string MSX. And we can get these test cases right. So we have y, which is new size. We have x, new size. We have case L, which is again a new size. And finally, we have the expected, which is a string. Expected starts from yx from a certain direction. So we have a direction which is a pair of pair of I32. This is the direction. This is the length. This is the expected. This is a test case and ours. We have refactored the test. So let's write it again. Let's go with another example from 3 in direction of -1 from 2 actually. I want to get x as m, right? It works. Now we have a direction of 4 on the horizontal line, so we are not moving on the y, we're moving on the x from 2 to, which is here. I want to get 4 characters, xs, xm. It works. If I go from the same direction in the vertical line, I can get xaaa. create. Okay. I need to change the direction. I want to go vertically down. Okay, now we have this get string. So we can remove the neighbors. We don't need them, but we can check. For a simple character, we don't need the count. We don't need the neighbors. Let's just get over with part one. So check position of y and x. Now here we filter. So if we check the position, we get a boolean. First, we can check on any characters. We want to check that the string is equal to something. We don't even need to do that here. We can do it in part one. So we have a grid, which is grid new of input. We can check for the position. So pub fn check position is a Christmas. We need to count Christmas for each character s. So we will do that in part one, and then we can repeat. So we can either get an x and check every Christmas which starts from there, or an s and check for every Christmas which arrives there. Let's try with okay, we can check for any x because it's easier. We can just check it returns Christmas for every possible direction. We had the direction in the neighbors, so let's get back to our neighbors code. It's not here. It's here. Let's go on until we have part one. Now, for every position in our grid, right, for any x in the grid, if grid of y by grid width plus x is equal to x. And if it is, then we check. Then we can, in any direction, oh, I forgot. Direction is a vector of there. Let's do it again. -1, -1, -1, 0, -1, 1. Then we have 0, -1, 0, 1, 1, 1, 0, 1, 1. These are the directions. For the indirections, the count, no, the actual count is outside of this. We need to count if grid get string of yx in the direction for 4 characters is equal to Christmas. And then we increase the count, right? And then return this count. Part 1 test is now failing. we need 18. It returns 18. We can solve the part 1. Try to solve this and go on with the second part. We can solve this and get the right answer. Okay, now that we have test passing and the part solved, we can clean the code a bit. So this is quite ugly, but it's okay. And this counting is also ugly, but let's see the second part. Did I misunderstand the assignment? Because he's looking for a X mass puzzle in which I am supposed to find two mass in the shape of an X. Ooh, this is quite different. Okay. One way to achieve is like this. Irrelevant characters can be replaced with a dot in the above diagram. Within the X, each mass can be written forwards or backward. Oh, so we have to check for mass which are written like this. Okay. In any direction. Here's the same example. This time all of the X masses have been kept. Okay. So they need to be in X. Okay. Okay, this is quite different from the algorithm here, so we will not do that. Okay. Now here we can just do a neighboring search instead. We need to have two M's on one side and two S's on the other side of the M. They cannot okay. Now this can be done with a neighbor search. Let's do it directly from here. Otherwise we will get really bad. So we can check from a single position the neighboring characters and see if they are right. So check X mass like this in a self grid with Y and X with return boolean. Otherwise we will get mad. How can we do that? We have directions, which are here. We have the grid. We can get all the neighbors, so directions. We can map them to a given position. So we have a direction, the Y, the X. Also, we want to get an X over the. We can just check for the X actually. So we can get -1, not -1, 0 because it's above us. -1, 1, which is the upper right side. We don't need these zeros. And we don't need this 0. We just have 4 characters to get. And we can check for different strings. So we can get the string from the upper side. Let's visualize that. So we want to get the M, A, M, S, and S. So in this case, we will get a string like MS, MS. Another case, which is okay, is to have two M's here and two S's here. So we get MM, SS. Another case is this one here, in which we have the S here and the M here. Let's try all the cases just to be sure. So SM, SM. And the other case is with S and M. So SSMM. Now, which cases are not covered here? We are covering every case. No, we don't have, for example, MSSM and SMMS. So we will check against these four. Again, let's get the string in the form of an X around a position. So given the distances, we map it to y as I32 plus dy and x as I32 plus dx. We filter out the ones which are not in the grid. So here we have y and x, and we check that y is more or equal than 0. Y is less than self height, x is more equal than 0, and x is less than self width. After we filter, so let's do it on multiple lines so it's easier to see. After we filter this, we can map them back again to the grid. So self grid of y as new size by self width plus x, and we can collect them as a string, which is this string. Let's say that this map doesn't work because we need an iterator over the directions, and this height we need to see this on the x and y. Why it's not working? Height as width and 32, and here we have I32. Now, as new size. Sorry. So now it should be all U size. We have the string. We want the string to be in these four cases. So match S. The string can be of type one of these four. Otherwise, it's not a right X. One of these four. Any other is not right. One of these four cases is okay. Can we use an OR in the match? I hope internet is working. Can we match for, yes, we can match for an OR. Here we can just use OR. In any one case, this is true. Otherwise, it is false. These should not work because they are string. Okay, so S as string. This check Christmas should work. And now let's do part 1. So we have a grid. We have, let's see the test failing. So we need just 9 of these. Okay, it's returning none. Let's copy the loop here and just change the condition. So if the one inside is an A and check Christmas of YX, then count plus equal 1. It's working and it's solving with a different number, 1969. Hope it's the right one. Yes. So we solved also these two stars. Let's clean a bit the code. So I didn't test too much here. It's my fault. Also, yeah, okay, let's just check Christmas here. Is fine. I got string here, but these two loops I don't really like. First, I don't like these two, so I want a get char from self, which given a y, which is a new size, the next, which is a new size, returns a char, and that's this part right here without the usize casts. I also want one with I32. Can I do that? Is there overloading? No. Get char size. Get char. Is there a way to like get a Rust generic size? Let's see if Stack Overflow helps us. Okay, you can use a trait bound. Okay. For example, I can T into, okay. I can do it with Y and X, in which, okay, so I can get with T, which can be transformed into a U size of Y of type T and X of type T. I can do into and ry into. These are Y. And this is nice. Again, this is self get of ry rx should work. Usize. Okay. He doesn't like that. So I32 into size. Not possible. No. No. Okay, I cannot do that. I can just get it from I32. I32 y as size x. I'm always using it as your size. Here I can get from this. Here I can do self get from yx. Also, the condition is the same. So is inside. Again, we have a self, and we have y and x. We return a boolean. We get this condition. This condition here without the asterisks. This is inside can be used here. We could try with the pair, but we can just do self is inside of y, x. Same thing here with is inside of ry, rx. And close. And let's see if everything still works. Okay. And no, we don't need this. It's not exactly the same, but it's okay. We can try to refactor this. So say directions is actually this first part. These are coordinates. These are coordinates, and then I do coordinates iter coordinates filter like this, or I collect it as a vector. Or I take the, and this same thing can be done here. For example, directions can be called coordinates, and here I can extract this part. For example, get coordinates, but this is not an iter of a map. It should be an iter over an i32. So it should be iterator. I don't know if I can do that. Of i32. No, it doesn't work like that. I must say item equals, no, yes, impl iterator of item i32. Here I can get the chords from here. Also, I can collect them as a string. Again, here I can do self get coordinates, and it should work the same way. No, it doesn't combine anymore. And these coordinates, this is a vector, so I need to do I need to get an iterator. I need to get an iterator from here. It doesn't like that. Into? No. Into iter. Okay, into iter. Like, it might like. Okay. And this is not working. Okay. Fair enough. Fair enough. But why? Because from the directions I need to get the coordinates. So actually this is iter map, and then add the, yep, exactly. So this was different. Here I get the coordinates, so I need to create the coordinates here. and the coordinates are from the directions. Yeah, it's more complicated than that. From the directions, I need to map not I, but dy dx and do dy y as 32 plus dy x as 32 plus dx. And then I can use chords. This should work. Yes. Again, I can use the get, for example, grid get of yx equal a. Same thing here if self grid get of y x is equal to x. This should pass again. Now I can just do this. This is okay. I think it might work. It's not the most elegant code, but it's working. And I don't like it, but it's okay. Okay, so we solved Advent of Code part 4. We checked in this location. He is not there, the historian. So we will look for him tomorrow. And thank you for being with me for all of this time, and see you. Bye.